In this video, we're going to talk about collision domains. So what is a collision domain? Well, a collision domain is simply a network segment in which data collisions can potentially occur. And when we're talking about a network segment, think of a network segment as nothing more than a local area network, because when we're talking about switches and hubs, they're utilized in local area networks. So specifically, a collision on a local area network where, let's say, we have multiple different devices on that network and they're sending and receiving data at the same time, where data is potentially colliding on the network and becoming corrupted, that can occur when we're utilizing a hub or a switch in half duplex mode. And as a quick refresher, a switch can communicate in either half duplex or full duplex mode. In half duplex mode, which we talked about very early on in the course, that's when computers are set up to send and receive data, but not at the same time. Full duplex is when you can send and receive simultaneously. And so we'll talk about this a bit more as we continue on in this lecture. Now, how do we mitigate collisions? Well, we mitigate collisions by utilizing something called CSMA/CD, where CSMA/CD stands for Carrier Sense Multiple Access with Collision Detection. So I have a lecture dedicated to CSMA/CD, where I'm actually going to walk you through a process flow that helps you understand exactly how this works. Now let's jump to the next slide and let's talk about collision domains, specifically with some diagrams talking about hubs and switches in half duplex mode. So with the help of a couple of diagrams, let's talk about collision domains a bit further. And what we're going to do is we're going to start off talking about hubs, then we'll talk about switches in half duplex mode, and then on the next slide, we'll talk about switches in full duplex mode. So what hubs do, hubs create one large collision domain that we have depicted down here. Everything within this diagram is one single collision domain, meaning collisions can occur all throughout this network as one large collision domain. Well, why is that? Well, if you remember from our lecture on hubs earlier on in the course, a hub is a multi-port repeater. So what is a multi-port repeater? Well, when we talk about it as being a multi-port repeater, any data that comes into a port is going to be repeated out to every other port. So for example, computer 1 here, sending some data over onto the network. Well, it's going to go out this port to this device. It's going to go out this one to this device. It's going to go out this one to this device. And any other device on the network that's connected to it, it's going to go out all those other ports. Same thing with number 4. And let me get rid of my writing. If number 4 is trying to send data at the same time as number 1, what you're going to get is a collision that we see right here. And this is not the only issue, because if we replicate this, let's say that number 3 is trying to send data at the same time. Again, another collision, right? And I'll just go ahead and kind of draw a collision right there as well. And then number 2, sending data at the same time, bam, another collision. So as you can imagine, this is a very small network. And if we expand this out maybe to just a network the size of 10 computers or 20 computers, that's a lot of collisions. So that's the issue with hubs. And as you scale up, collisions scale up a lot as well, and it really degrades the performance of your network. And that's one of the primary reasons why we don't use hubs anymore. Now let's go to switches in half duplex mode, because that's an improvement. So if we take a look at this diagram, we have 4 different collision domains. So rather than one large one, well, we have a collision domain here, we have a collision domain here, we have one right here, and we have one right here. So how is this an improvement? Well, whenever you can decrease the size of a collision domain, that increases network performance. So if we think about the way that half duplex works, half duplex is designed where a device can send and receive data, but it's only designed to be able to do so one at a time. You can only send and you can only receive. And if you think about it from the perspective of the network cable, think about it from the perspective where they're using the same exact wire to send and receive. So if you're sending and receiving at the same time on that one wire, what's going to happen? Well, like we see down here with this example, we'll get a collision. But here's the great thing. Because a switch is a smart device, computer number 1, it's going to send data out into this physical port, and that physical port's going to send it out to this device, and it's not going to be repeated out to computer 2 or to computer 3. So there's no chance for a collision on computer 2's collision domain or computer 3's collision domain. The only place in which a collision can occur where computer 1 and computer 4 are communicating back and forth is on collision domain 1 and collision domain 4. So again, if number 4 is sending some data up here at the exact same time as computer 1, we'll get a collision. So, and that's where CSMA/CD comes into play. So how do we mitigate collisions with half duplex and also with hubs? Well, because we now really only use switches, to mitigate these collisions, we use CSMA/CD. And we have a lecture dedicated solely to CSMA/CD in this section. So we're going to talk about that. Now let's go a step further and let's talk about switches in full duplex mode, because that's a drastic improvement over hubs and switches in half duplex mode. So when we have a switch that operates in full duplex mode, we eliminate collisions altogether because, well, collisions simply don't occur on switches that are operating in full duplex mode. Well, why is that? Well, as you see depicted here on this diagram at the bottom, we have a switch that's connecting two systems together, and you're going to see that there are two separate channels. There's a channel that's dedicated for sending data, and there's a channel that's dedicated for receiving data at the exact same time. And if you think about it from the perspective of a network cable, think of it as one cable for sending and another cable for receiving, and it being designed so it can happen at the exact same time. So that begs the question, why would we use half duplex mode? Well, when we don't have to, we won't. In 2021 and beyond, essentially all devices, well, most devices operate in full duplex. But if you come across a device that's operating in half duplex, then the network's going to operate in half duplex when it communicates with that device. And if you have legacy equipment, well, that's a good reason for having to use half duplex. So you would realistically only use half duplex when you have to. When you don't have to, you're definitely going to want to utilize full duplex. And another added benefit of full duplex communication is that we also get increased network speeds as well. So not only are we eliminating collisions, but as you can imagine, because we're sending and receiving data at the same time, our network speeds increase as well. So that's going to conclude our lecture talking about switches and hubs, and specifically talking about how they pertain to collision domains. So hopefully you now understand that hubs and switches in half duplex mode, when we utilize either of those devices, we have the potential for collisions, but when we're utilizing switches in full duplex mode, collisions don't occur anymore.